You're listening to the Talking Air Filtration podcast, where you get to know the people that make air filtration possible and help us all breathe easier. Because clean air matters.
We'll get insights from air filtration professionals and learn how they became successful in their careers. Along the way, we will discuss best practices, guidelines, trends, and challenges in air filtration in a variety of applications. We hope HVAC, air filtration, and indoor air quality pros, including business development, engineering, building owners, and facilities management, will enjoy the insights our guests will bring to this podcast.
And now for our final session of the day, installing UVGI lamps inside an HVAC system can improve indoor air quality by reducing the presence of microorganisms such as bacteria and viruses. And there are several types of UVGI systems that can be installed. Today we will hear from two UVGI experts who will provide tips and techniques to properly size and install different types of UVGI systems. Please welcome NAFA members Jay Carter of Sanuvox and Dale Harrison of Fresh Aire UV.
Well, good afternoon, everybody. How we doing? Let me introduce myself. My name's Jay Carter. I'm the VP of Sales with Sanuvox Technologies. And we have a very unique situation for us today, and probably you guys too. We're two different manufacturers coming to the same stage to talk about the same technology. So what our goal is to ditch all the stuff, right? All the, well, this thing does this and mine does this. We want to get down to the science. Let's get down to what kind of application we're doing. But let me introduce Dale Harrison. Your title's VP, I don't know. I can't keep up with it. Everybody's a VP around here, right? Yep. So what our plan today to do is I'm going to go through a little bit of, we're just going to kind of share the time. We're going to actually keep it pretty brief, go through some real top line, broad ideas and topics on the subject, go through some of the installation stuff, and then back up, and we'll probably catch a chair, sit down, and have a discussion, right? Because there's lots of questions, and we can't know your questions until you give us a question. All right, so let me get started. Is this thing, all right. So here's kind of a guideline of what I want to get through today. I'm gonna go pretty quick. But what is UVGI? There's always a confusion, and I'm sorry, but I can't not discuss it, but frequency and intensity and dose. Everybody gets wide-eyed, so you're only gonna need about 20 minutes of me completely dweebing out and deal with all of these terms and things. No, in reality, I'm gonna hit it very high level. I'm gonna talk about it and go through that. Then we're gonna get into different types of applications, talk about the electrical, how the lamps lay out, what do you do with the systems, and different sizing requirements. What do we need to know? What are we trying to do, right? What's our goal that we want to use the UVGI for? So first off, I want to establish just a few of the facts. UVC, germicidal, is classified at between 100 and 280 nanometers. So that's the measurement of light. That's the frequency of the light. The peak efficiency for most germicidal effect is 265 nanometers. So we're just going to get just a few key facts down. The most efficient electrical delivery of that, because there's all kinds of different technologies, right? You can put UV in many, many different ways, but the most efficient from what's burned to UV output is low pressure mercury vapor lamps. They produce 253.7 nanometers. So it's very, very close to that peak germicidal efficiency side, right? So that's what we talk about 99% of the time. There are other technologies out there, but you start having pushback and different things. So specifically, we'll be talking the most about mercury vapor. Additionally, and this one I'm gonna love, surely somebody in the room is gonna get me on this one. Ozone is formed anytime if the frequency is below 240 nanometers. I don't even see a single, nobody's crawling. I really figured when I said that, they're like, There are misconceptions out there. You can't, that's fact. That's the science. At 240 nanometers and below, that UV has enough energy to break the bond of oxygen. If it can break the bond of oxygen, Cold, hard scientific fact says it's going to form ozone. No questions, no buts. Well, but 222 or this or that, it's going to form ozone. So you have to pay attention. If you drop below that frequency, pay attention and be careful. Doesn't mean you can't use it. It just means you can't start getting past those OSHA standards and the safety concerns that we have with other. There's ozone in here right now, and we're all fine, right? So we know about those indoor air quality things. So what is the term intensity? Well, intensity is the measurement on a fixed surface of at a specific distance of how much UV is on it. It's measured in microwatts per centimeter squared. I'm sorry, I gotta do some of it, but these terms and those letters and those things are things that we need to be able to see and things that we be able to comprehend what they are. So I want to just kind of define them a little bit. So microwatts is physically measuring how much light is on that surface. And that's not the literal term, but that's basically just that. It's the amount of UV power there. The most we use this thing for is in HVAC applications is cleaning evaporator coils, right? So Aire recommends between 100 or between 50 and 100 microwatts to say you're going to adequately clean and keep the microbials off of that evaporator if you're between 50 and 100. Most manufacturers will step that up to about 250. And it can get very confusing. Well, what's this here, and how much here, and minimum over here? A manufacturer should supply you a document of a picture of that lamp layout and show you what the dose is. So think about it as simply as this. We want the minimum dose, in other words, the farthest corner in the room from that UV light to reach that. My recommendation and his are pretty close. We compared notes to that 250 number. The number will go up from there, but we know at that point it's going to do the job that we need it to do. Okay, does that make sense? Now, from there, you take that intensity number and then you start taking reductions out of it. So every inch that you move away from that lamp, the intensity reduces. So the farther away you put the lamp, it goes down. That doesn't mean it's ineffective. You can still have UV power at 10 foot away. It just means the number's less. So it's a factor. We have to think about that when we're sizing and we're looking at these air handlers, we have to think about mounting distance a little bit. Lamp cooling effects, wind chill. So if you have cold air blowing across a lamp, guess what it's going to do? It's going to cool that lamp and it's going to drop its output slightly. So it's a factor. We got to factor it in. Lamp fouling effects. I put in a word that I thought maybe, do we use that ever here, particulate? Has anybody heard of that? Just kidding. So particulate can blow into the face of that lamp and then foul it, right? So it literally, the pores of the quartz can hold particulate, and what would that do? It would reduce the intensity. So all these different things are going into it. And then of course, the most common and what gives us the hardest time is reduction in capacity based on burn time, right? So lamp aging comes into it. Most UV manufacturers say change your lamps every year. Some manufacturers say change your lamps every 2 years. How do we know the difference? Because that sizing report that manufacturer supplied you in the beginning told you what that intensity was going to be at the end of their recommended life. Not today. And be very careful about that. There are a lot of, I don't really have the term, but it's all over the board, guys. I promise you. You can go to a manufacturer X that just started last week and you say, oh yeah, this is 100 billion gigawatts. It's perfect, it's just what you need. And maybe they have a report, but it's today. And then tomorrow it's less. And by a year, it's nothing. So know the data from your manufacturer, talk to your manufacturer, get it on page, and then talk to your consumer about that. Your end user will want to know these things because they need to know their maintenance cycles, right? So now I've got to take it one step further, and then I promise we're going to bring it all back, right? We're going to talk about something a lot more fun after that. Dale. So dose is the method for measuring UV effectiveness in an environment, right? So think about it like the caliber of the gun. So if you're going mouse hunting, you're going to need a smaller gun. If you're going elephant hunting, you're going to need a bigger gun. So you're going to need more intensity. So depending on what microbe we're trying to attack, we have to know what kind of gun, how much intensity to put in that thing. So by definition, the UV intensity is microwatts times time of exposure in seconds gives you dose. So if you put 100 microwatts on this times 60 seconds, now you've got 600 microjoules of power, or microwatts per centimeter squared. So this is where it gets really confusing. There are a lot of different ways to write that intensity number. And this, I think manufacturers just do it to keep, I don't know why we do it. I don't know why the industry does it, but there's literally 3 different ways you'll see that same thing written. Then the only difference is it's a difference in unit of measure. So if you look at the bottom of the page, it's the bottom of the screen, it says 1,500 microjoules per centimeter squared is exactly the same as 1.5 millijoules per centimeter squared. What in the heck is that guy talking about? My point is, talk to your manufacturer, get to understand it. But thank God for Aire, because now they've got involved and we're starting to see these dose numbers. Because intensity alone doesn't do anything. You have to have exposure time for it to reach its end goal. We can't purify the planet in a split second. So it's a time and intensity factor. You got to combine the two things to get to your net end result. So Aire had done quite a bit of work and done some nice things and published for recommendations. So for SARS-CoV-2, we know as a manufacturer, they recommend about 1,500 microwatts times seconds per centimeter squared. Or the same exact number is 1,500 microjoules per centimeter squared, 1.5. How bad did that get? Are we like, oh my God, this guy, I lost. So long story short, I wanted you to see it because sometimes it helps to see these different numbers and maybe hear somebody speak to the difference. It's not easy. I accept that is intentionally complicated, but it's really not. It's different people putting different numbers. You just need to make sure that you're talking about either intensity of a lamp on a surface or the dose, meaning we're delivering, we brought in a big enough gun and we just killed that mouse. Does that make sense, I hope? So now when we start getting into different types of application, so we go to a facility and we say, I got UV, do you want it? They're like, for what? Well, I don't know. Do you want it? I mean, how does that work? How do we get into that? Well, really, we're problem solvers. Do they have an issue that they need help with? Yes, probably. Well, as a matter of fact, there's water blowing off of my evaporator coils constantly. My filters are always wet. Is there any? Well, that could be a static pressure problem. Impaction. UV will clean all the way through an evaporator coil. If you set that coil clean up right, you can clean an evaporator coil all the way top to bottom, as opposed to chemically cleaning that coil when you're typically impacting in the center of that coil. You're gonna make it worse continually. So if you ever have a project, do us all this favor. Any one of us, if you ever have a project where they say, well, we're getting ready to change these evaporator coils. Has anybody ever heard that from a customer before? Has anybody ever been in? I've actually heard it several times. Just pause, just say, whoa, time out, 1 second. That $500,000 evaporator coil change you're gonna do, what if I could fix it for 10 grand? Would you be interested in knowing more about that? If you can do that and ring somebody that can give you some of this information like us, they will love you for the rest of time. I don't know any other way to explain it. And that's what coil cleaning can do. We're destroying microorganisms and getting rid of that impaction. We're giving their system back to them. We're bringing their capacity back. Air treatment, that's when we're getting into the airborne microorganisms. What we really need to know, SARS, COVID. What we really need to know is the CFM and the speed of the air, because that gives us our contact time. We're trying to kill something moving, so we need to know the speed of the air and the contact time so we can choose an intensity and figure out how long I've got in contact with that germ to give you the kill rate that you want. I want to kill 99% of this thing. Here you go, put this in. So it's really kind of, maybe I've done it in a minute, but it's pretty simple, right? It's how much light do I need? How big a gun do I need? And then when we're dealing with upper air, so upper air, and I'll have Dale join me, but when we're talking about upper air, we're typically talking about, because it's the one that's gotten all the attention, right? It's the one that you've seen from the White House. It's just UV. What upper Aire is, you're gonna need to know the square footage of the room and the height of the room. It's a light that sets up there and shines a passive light pattern across the ceiling. We're gonna show you and get into it a little more in just a second, but you just need to know the room size, ultimately. And they're made for small spaces. So you would put several of them in here, 250 square foot per unit maybe. And they vary by size, of course. But then portable units, that's a recirculating system. So we're just wheeling a unit in and we're rolling out. So we need to know the same thing. We just have to know how big the room is. How many air changes are we going to get through that portable system?
Are your air filtration personnel NAFA certified? Ask if they belong to NAFA and have their certified air filter specialist or NAFA certified technician designations. The CAFS and NCT designations are earned after rigorous exams and demonstrate that the air filtration professional has a high degree of knowledge and professionalism. To learn more about NAFA certifications, visit nafahq.org.
Air disinfection. So you're looking at a couple, there's actually 2 or 3 different types of applications here. You'll notice the 2 in the middle are designed to go in line with the air stream or parallel to the airstream. Why would you turn your lamps that way as opposed to the picture on the right? All of these are coil cleans, or all of these are air treatment systems, but why would you turn the lamps one way versus the other? It's about contact time. If that air has to blow down that lamp longer, then it's probably going to have a little more time of exposure. If your time of exposure goes up, your kill rates go up. Pretty simple. So you can do air treatment with either type of system. You're going to have to put in a gigawatt, for lack of a better fake term, onto the ones on the right. If you're going to put it in a coil, you're going to have to put a lot of power. You're going to put a lot of wattage in it. If you truly want to get it, you're going to have to put a lot of wattage in it. So the lamps, when you go into one that's really sized correctly on a coil, it's going to look like this. There's going to be 20, 30, 40 lamps on that thing. And if you go into an Airstream, like one of those 2 right there, those 2 small fixtures with only 5 lamps, you probably have the capacity to take care of 40, 50,000 CFM. So it's not, and our wattage is 1/10 of what it is, because a watt is a watt is a watt. Watts and amps and I mean, we all know some of that data, but ultimately, you got to get X to get X. So if you have to put in 20 lamps, pull in 10 watts apiece, or not 100 watts apiece, and you got to put in 100 lamps, which one's going to have more consumption? The 100. So different applications like that. Coil clean disinfection. We already talked about it. Here's a couple of different ways. Different manufacturers have different recommendations. We all typically would agree, ideally, you need this much intensity. So that's a good example of 2 pretty good size evaporator coils. You got reflectors, you've got different options, you've got different mounting. The way you mount these things are kind of like an erector set. And I actually like this picture on the left because it shows you mid-installation. So functionally what we're doing is we're putting in vertical or horizontal mounting bars, and then we're mounting UV lights to them based on what the manufacturer recommended for sizing and layout. So then from that, you're going to have a ballast box mounted outside the air handler that's going to have to drive it. So, and that ballast box will depend on how many lamps, and one manufacturer will need 1, and a next manufacturer will need 5, and that all is OEM specific. It's how that manufacturer compares their thing. Not all UV lamps are created equal. A watt of UV is a watt of UV, but not all UV lamps are created equal. What the heck did he just say? They're just not, right? Because that ballast and that lamp are combinations. So if you take his high quality lamp and put it with my high quality ballast, we're oil and water. We got 2 different manufacturers here, and we're doing just fine. But at some point, we're not going to get along, and those 2 things aren't going to work. So you're going to end up with your customer. And one thing that we deal with a lot in our industry, more now so than ever, and you can tell me if you agree or not, but Chinese knockoff lamps. I don't know if I can, but they import these lamps that say the same specs, but they're not. And it's fine to use them, but you haven't sized them to that. They're not OEM specific. And it's the same thing that you deal with your automotive, right? You can either get OEM quality or you can get aftermarket quality. And that aftermarket quality hasn't had any standards to it. So we've seen lots of failures, and it's hurt our products because of these aftermarket things. So we caution you on the aftermarket side, regardless of where they come from. Do you got anything to add to that?
Yeah, that's exactly correct. I mean, that's our biggest problem as manufacturers, is making sure that the end user is using the exact lamp that it was sized for. You know, and especially since COVID, you see a lot more and more aftermarket lamps out there. So it's really important to stay with what you started with when you're using a UVC product, because especially when we're providing that data to making sure that we have that continuous dosage through that lifespan of that unit. So that's very, very important. But going to the upper air, obviously that is a kind of a product that's been rejuvenated since COVID. It's been around actually before air conditioning. It's been around since the 1930s for the treatment of tuberculosis, when people were actually putting it in classrooms, hospitals, and it's still used in that type of setting. Now you're seeing it in airports. I've seen it in multiple airports. You know, anywhere where there's, you know, face-to-face, you know, issues. And what it's doing is obviously creating an energy beam that's shooting across the room space. So you really don't need a forced air fan to do that. So you're just actually, natural air convection is helping sterilize that space. So it's a very effective unit for commercial, industrial, when you have that room contaminants, when you need a little bit more coverage than just circulation from the air conditioning system. You can combine the two together. There's a lot of manufacturers that, you know, suggest both depending on the situation, or you don't have any natural, you know, HVAC ventilation, and that's the product to choose from, for sure. Anything to add to that?
No, that's right. I mean, just talk to your, thank you.
Oh, okay, great.
Just talk to your manufacturer. Get their recommendation. But we got to keep in mind, what are we really doing? What problem does that end user have? Don't go try to sell a solution. Go try to find their problem. Be a problem. So don't force the solution. You can't walk in there and say you need coil clean lamps. Oh, you need these air treatment lamps. How do you know they need it? Well, everybody needs it. Well, that's fact. As a manufacturer, I say that for sure. But is it really what the customer needs? Now, that's not the best sales pitch, because it's that, you know, the real good sales pitch is sell everything you can every time you can. Okay, that's good. But my point is, let's get them what they need. And if we can be consistent in our message to offering solutions-based cures, then they will start to trust the industry, because there's been so much smoke and mirrors or snake oil that's gone to air purification and air treatment and all this air things before. We know that. It's not us, I promise. We're trying to keep the science up, but we need everyone to help us get the message out, really. Because we can talk to everybody to the blue in the face, and I do not expect anybody here to remember how much? A third of that stuff that I started with? But just know that it's real. Know that it's a common sense scientific approach, and you can get, that's the beauty of dealing with this UV. You don't have to trust us. It is documented for hundreds and thousands of papers. This is what separates UVGI from other said air treatment systems. I'm going to try to say this as delicately as I can, because I don't need any cease and desist letters tomorrow. Peer-reviewed documents. Peer-reviewed study. Well, of course, we say that, but yet we're selling tens of thousands of systems that's never been tested or reviewed by a peer council. Why is that? Well, because, Dale, this piece of paper says it kills stuff. Great. Go to a source where you can find something that someone tested it in a lab condition, and then it can be replicated. And then the next lab replicates that test, and if they agree, now they've peer reviewed, and this document is real. That science is valid. It's been validated. It's been peer reviewed. I'm not speaking to anything other than UVGI is very, very, very well peer reviewed for the last 50, 60 years and earlier. So it's a cautionary tale. I guess I would say. Then we also have portable solutions. I almost forgot those. So you can roll in a unit, you can put UV, you can add HEPA, you can have UV only. That comes down to air changes per hour, right? So you take this room and you pull the air in. There's no magic bean, kids. There is no such thing as little magic Pac-Man that can go out to the space and sterilize every little thing. Just doesn't exist. That's a good story. It's not real. There's no true peer-reviewed science that proves that can happen. However, you can poison a room, right? So if you put in enough chemical into a room, it's probably going to kill things. Is that a fair assessment? Now, I'm not calling other things poison. Certain indoor air quality devices can decrease indoor air quality. They can add formaldehydes to the airstream because they have incomplete decomposition. So be aware, do your research, but no, UVGI at 254 adds nothing. You're only killing microorganisms. You're not changing the molecular structure of anything. You are not damaging that room. So other things you could add, and we can debate that. I hope that I've got somebody a little riled up in the room because I need somebody to pick on me in a minute, or him at least. But we kind of wanted to talk about the installation side. We hit some topics there, but we kind of wanted to talk the installation side about with you guys, meaning what questions do we have? What are we confused about? I mean, is it all cut and dry? We all know. I'd like to open the room up. Do you have anything else you want to add right here?
I do, yes. You're 99.9% correct in our disinfection world. But
I'll take it. I'll take it.
The biggest thing is when you're looking at a project or you're looking at an existing system and you have a customer that's interested, is providing the correct data that we need for sizing. That is our daily battle of knowing the type of system, if it's a chill water system, a rooftop package unit, or whatever it is. It could be a small fan coil, is giving as much data as you can so we can be exact as possible to provide that dosage and that kill rate. That, as all manufacturers, that's our biggest hurdle, is gathering the correct information from you in the field to us, because that's really, is what everything's based upon. Is once you have that information, the next step is installing it properly. I've seen many companies is once they actually get the information, they'll turn around and they'll put the lights vertical, or they'll put them right up against the filters, and everybody knows, hopefully in this point, there is not a UV resistant filter out there. So that is the biggest hurdle. Is the next step is making sure that you're installing it properly. Is that information of feeding back, to you guys, is you providing the information, and we make sure that the end result is what the customer's looking for. Because all in all, it's really the installation that you're going to get the results for at the very end. So, yeah, but we'd love to hear your feedback and questions or anything you may have.
Is there any special requirements, protocols for replacing or disposal, I should say, of the tubes after they're
the lamps? Yes, exactly the same as you would handle any fluorescent lamp.
Correct. Yes, your recycle center.
You use
Same
your
way,
recycle
like
center.
crushed and into glass, and then just
They'll
recycled, or can
that's
it be
correct.
recycled too? Or?
Because these lamps are nothing more than glass and trace amounts of mercury. I mean,
Just mercury vapor.
Vapor. It's
Vapor,
not even measured. It's a gas, right? So it's not. There's very little to it. So you're really just maintaining the gas. It's the same as a standard conventional fluorescent lamp.
And from your experience, are you seeing a lot of installations into new original equipment? And I'm specifically thinking of larger rooftop units where they're designed and installed before they leave the factory, or?
Yes, there's a lot of OEM programs. Those are actually picking up at a much higher rate post-COVID, I would have to say, because the equipment OEMs know that customers are wanting UV. Now, the challenge with that, and in my opinion, and this is just my opinion, the challenge was that the equipment manufacturer is going to go out there and say, check mark the box, put UV in it. They're not going to be considering anything but what it's going to take to clean that coil. So we want to be careful of, is the customer really getting the air disinfection that they want, or are they just keeping their coil up to clean? Because nobody has a conversation between the end user and the manufacturer of the evaporator equipment about this is going to deliver this much dose or that. They're just check marking a box and saying, yes, put this in. That is something we're working very hard to educate these OEMs with. I mean,
Yeah,
honestly.
we see a lot of specifications out there, and J.O. agrees, almost all of them are totally different, depending on the manufacturer, and that's what we're trying to do as a Unity, is making it more consistent. But you are seeing more on the OEM side, for sure.
One of the slides here indicated that you can use the UV for coil cleaning. In a situation where you have a serious amount of calcium buildup on the system, would you recommend UV for a situation like that? And would that actually clean the coil?
Are you talking like a biofilm mold growth on
Or
the
like
coil
a
itself?
scale.
Coil itself,
Like a-
yeah.
Like a scale calcium?
Correct, yeah.
Okay. Yeah, if that's the case, UV is not going to be able to dissolve that directly, so it's better off to clean it first and to do that.
You will be able to help with it. So in other words, if you can get it descaled, you'll be able to help with the formation because that calcium won't have the biofilm to stick to as easily. So the water wicking down the drain, down that coil will keep that calcium buildup. It will slow that calcium buildup. Can't say that it will cure it all the time. It depends on your application, but it can slow it.
Is there any technology out there that can descale the calcium buildup without taking smell, odor into the system?
Not that I know of.
Because
No,
that's
I don't
something
think
I'm
so
really
either.
concerned about. You could use chemical or some compounds to descale, but will that transmit any kind of smell?
Chemicals.
Yeah.
You're always putting, really, calcium's a pretty tough one, so you're gonna have to physically clean it and get it out, you're gonna have to put a chemical in it to neutralize that calcium.
Yeah, in some cases, you're going to be better off cleaning it first and then putting UV, especially if you have a different situation where it's not more of an organic, that UV is going to take care of.
With people who are concerned about ozone, even if they've bought the right system, is there any sort of monitoring that you have or that you would recommend that they could just monitor what is the ozone level?
Some of us as OEMs, we do utilize some ozone detectors. It's typically made to use a lamp that's producing ozone, but to control it, right? So you'll have a manufacturer that'll put an ozone detector in the room and then say, okay, I've got a high odor and I know I need this UV destruction, the ozone forming UV. I know I need that to kill the odor, but then it can overcompensate and create ozone. So then that ozone detector can turn it off. Additionally from that, so that's a manufactured rig combination pair. Additionally to that, there are several types of different exterior monitoring devices. And I know there's a lot of great ones in the NAFA partnership. I don't have the particular models in hand, but I've seen many, many, many of them that work very well. But if we're UVC at above 240, so the standard 254, there will be none. There will be no forming of ozone.
That can't change over a degradation of the.
Nope, never.
No.
Because that light is coming out at a set frequency. And you have to be below 240 nanometers before you can break the bond of oxygen. It's a double bond element, and when it breaks that O2 molecule, it breaks it in two pieces of oxygen. And then that second piece of oxygen, now we got two independent pieces of oxygen, it's going to go to the other, that's a radical, if you will. So that radical is now going to attach to an O2. So if you take one O and you add it to an O2, what happens? Boy, it is getting late.
Crickets.
Anybody? O3, it forms O3, ozone. Yeah. So that's how it happens. It's actually a chemical process. It's the biologics of it.
Yeah, in our world, the only time we're utilizing ozone-based lamps is for exhaust outside of buildings. The way most specs are written now, it's pretty much non-existent at this point to initially use an ozone-based lamp in a commercial application. So
The most common is 185. 185. So what's the difference? How can you tell a difference? I think this would be a good question for everybody. How can you tell a difference between a 185 ozone producing lamp and a 254 non-ozone producing lamp? Man, that's a good, anybody guess? Hopefully it's labeled. Ultimately, you really can't. All right, and here's what you'll do. When you power that thing up, you'll smell an ozone lamp. Like that, right? So that's one. Two, the manufacturers will usually identify them differently. Like, we will change the color of the end cap of the lamp. So we know if you've got this color, this is ozone. If you got this color, it's not ozone. And on the lamp itself, it will be etched by the lamp glass manufacturer that it will say caution, or it will have the notes on that lamp.
Yeah, and there's also mixes where you'll see if you look directly at the lamp, you'll see like a blend where they take two types of quartz together and they'll have like a 10%, 50%. So there are different types of lamps out there that sometimes they combine 254 and 185 together.
I know some of those guys that do quite a bit of that. But so you can put in some 185 as long as you keep it at a minimum, that it just doesn't overly form. Because as long as you have chemical compounds higher than the formation rate of the O's, it won't build ozone. The chemical that it's destroying is going to use those hydroxyls first. Don't worry about all that. That's where your OEM will help you, right? So you can have a hybrid of both.
Yeah, and you need solely something for it to attack, or it's going to be free floating in the air, and then you're going to be breathing it in, and that's where people become hypersensitive to it.
Good question. Yeah. Next, UV is, well, we all know that it's hit the map about 2.whatever years ago, 2.5 years ago, 3 years ago. There was a thing called COVID. It was a whole pandemic thing. You might hear about it sometime, but that pandemic obviously put UV on the map, but it also put all kinds of other things on the map. And unfortunately in our country right now, today, we don't have any indoor air quality police. Anybody can sell anything that they want to sell and say that it does anything that they want to say it does. Almost. And that hurts us here. I mean, I don't know about this guy, but no, it hurts. It's painful because we're trying to teach the message and teach the science and understand how this works. And you can legitimately kill things in the air, but you got to do it right. And hopefully that this gives you a little bit of an idea of what's out there. If you have specifics on installation, now's the time. I mean, ask away on any of it.
Is anybody currently installing UV lights, or do they do it in-house, or you work together with a electrician or HVAC contractor to do the installation? You do, okay. And that's typically what happens, is because sometimes, most systems being 460, 480 volts, then you need an electrician to do it. And really, an electrician can do the entire installation. You necessarily don't need an HVAC contractor. And I'm speaking, being from that industry for 16 years, is a lot of times it's better just to have the electrician to do the whole installation at times, because you have to bring that separate source of lower power. Most ballasts are 120 to 277. So if you have commercial equipment that's 460, 480, then you need a separate source. But
all UVC ballasts that you're going to deal with are single phase power.
Electronic.
Yeah, that's right. Yeah. So put that, it's 99% of what's we're using now. It's everything
Correct.
we're using.
Everybody's pretty much using that.
So just be aware, get to single phase power. Beyond that, we can solve it. If it's 3-phase, we got to get single phase. And we need clean power. We can't run it off some kind of wicked, nasty circuit. You'll need a pretty clean power source.
Yeah, and most manufacturers, for the most part, try to make a turnkey application to where you don't need a lot of aftermarket parts. They'll have everything available to where you open the box, and really everything's there, from door interlock switches when you get those options, because you really do need those. Anybody ever been exposed to UV? I always like to ask that during a training. You have. And it wasn't a pleasant experience, was it? That's the unfortunate thing, is when you do have it, or you do see when you're looking at the air conditioning equipment, treat it like electricity. That's what I always say is, treat it with respect, because it really doesn't take long for it to, have a short-term effect.
About how long does it take to affect your eyes?
Seconds, sometimes quicker than that, especially if you open a door. Anything with a handle on it, especially your larger systems, needs a door interlock. Any access point, somebody opens it up, checks a fan, you need to be able to shut those lights off so it shuts off, because if a light's right there and you open up the door, guess what? You've already been exposed. But if it's like from me to you, you would have to be looking at it for a longer period of time for it to start to affect you. But that's the biggest thing, is to be careful when you're working around it, and make sure that you're training, the people that are in those vicinities where they're, around the UV.
Anything else?
Just clarification. So we brought it from a customer, they already have UV installed.
Yep.
But they're going through us to replace the bulbs.
Yep.
I have to look at the ballast to see who supplies those bulbs, because I just can't go to anybody or to replace those bulbs. I have to go to the correct company.
Correct. The ballast itself will probably be in a ballast box. That ballast box should have a model number of the system on it. So you'll want to get a hold of that manufacturer and give them that model number so that they can reference what combination it was. But yes, exactly right.
Yeah, there should be identifiers somewhere, even on the lamp
The lamp
cords, the
itself-
ballast.
Yeah. The lamp itself will typically have some numbers on it too. So you can do some research via that way too.
Yeah. Especially if you have different pin setups, if you have a single 4-pin or a double-sided, you got to make sure that you use the correct lamp for that.
That's right.
We do see a lot of that conversion being tried out in the field, and it never works,
Nope.
ever.
Nope, never. All right, guys, appreciate it. Everybody safe travels. Thanks for having us.
Thanks for listening to the Talking Air Filtration Podcast, a production of the National Air Filtration Association. Clean air matters.